Hello, hi everyone, coming to my channel Samuel Flying Birds. Thank you for watching all the previous videos which I have been doing, and in this chapter, in this video, we are going to discuss about the 10th class mathematics of chapter 4, linear pair of linear equations in two variables. We know what is mean by pair. Pair is nothing but two or by, or two uh, variables or a two quantity. We can say that two is known as pair, and linear equations, here we are writing an expression of ax plus by plus c. It is a linear equation. Coming to the variables, we can use a variable as two variables as x and y, a or b, p or q in the similar way. Now today we are going to discuss about what is linear equation and how can we write the expressions using the problem. Example: considering Lakshmi also brought the same type of notebooks and pens as Siri, she paid 110 rupees for 4 notebooks and 3 pens. So we have two situations. We can represent as first one, cost of 3 notebooks plus 2 pens equal to 80, and cost of 4 notebooks plus 3 pen equal to 110. Does this help us to find the cost of pen and notebook? Yes. Consider the price mentioned by Rubina. If the price of one notebook is 25 and the price of one pen is 2 rupees 50 paisa, then we write the values as for notebook and pen as the cost of 4 notebook would be 4 into 25, we get 100, and the cost of 3 pens would be 3 into 2 rupees 50 paisa, we get it as 7.50. If Rubina is right, then Lakshmi should have paid 100 plus 7.50 equal to 107.50 paisa, 107 rupees and 50 paisa, but she paid 110 rupees. Now consider the price mentioned by Joseph. The cost of 4 notebooks, if one of the 4 for 16 rupees would be 4 into 16 equal to 64. The cost of 3 pens, if one of the is for 16 rupees, it would be 3 into 16, we get 48. If this Joseph is right, then Lakshmi should have paid 64 plus 48, it is 112 rupees, but it is more than she paid. Now considering the example, here we are going to solve in a graphical method using the equations. Till now we have discussed how to write the expression or how to derive the expression from the given problem, for the given problem. Now the expression is given already in the problem. Now we are going to represent it on a graphical method. The first example: check whether the given pair of equations represent intersecting, parallel or consisting linear. Find the solution if the equations are consistent. Here we need to check two methods, two important terms. First, the equation should be consistent, and second, it should be intersecting or parallel or coincident. These three, if it is consistent, all these three will be undertaken. The first expression as 2x plus y minus 5 equal to 0 and 3x minus 2y equal to 0. 3x minus 2y minus 4 equal to 0. Coming to the solution, we write the expression, linear expression. We know that a1x plus b1y plus c1 equal to 0. For first expression, we compare both the expressions and we write the terms as a1 by a2 and b1 by b2 and c1 by c2. a1 by a2 equal to 2 by 3, b1 by b2 equal to 1 by minus 2 and c1 by c2 equal to minus 5 by minus 4. Since a1 by a2 is not equal to b1 by b2, therefore they are intersecting lines and hence it is consistent pair of linear equation. By considering the first equation, we need to find some of the points to plot on the graph. Now, considering the first equation, 2x plus y equal to 5. Here, if x equal to 0, we get y equal to 5. If x equal to 1, we get y equal to 3. If x equal to 2, we get y equal to 1. If x equal to 3, we get y equal to minus 1. If x equal to 4, we get y equal to minus 3. Substituting all the x values in the expression y equal to 5 minus 2x, we get all these points. Now, in the second expression, we are finding y in terms of x. We are writing the expression and substituting the values. X equal to 0, we get y equal to minus 2. And if x equal to 2, we get y equal to 1. If x equal to 4, we get y equal to 4. All these points we are considering and plotting on a graph sheet. By plotting all these points on a graph, we get the two lines are intersecting with each other at one junction or at one point. The point where the two lines are been intersecting each other, it is a solution of the given both expressions. It is considered as a solution of both the expressions. Here we are having only one point is been intersecting for the both the lines. So we are having unique solution in the linear pair of equations, that is 2, 1. Now coming to some of the points and some of the important terms about linear pair of equations, considering different types of examples. First example, 3x plus 2y minus 80 equal to 0. Here we are comparing both the equations. 4x plus 3y minus 110 equal to 0. Here we write the expression of a1 by a2 and b1 by b2 and c1 by c2 as 3 by 4, 2 by 3 minus 80 by minus 110. Comparison of all the ratios, we consider or we observe that a1 by a2 is not equal to b1 by b2. The algebraic interpretation is given as the expression is consistent and it is independent of each other. a1 by a2 is independent to b1 by b2. So they are not being equal. So in a graphical representation, we can observe that it is a intersecting points or intersecting pair of equations. There is only one solution in the intersection as we have observed in the previous problem. Coming to the second one, 1x plus 2y minus 30 equal to 0, 2x plus 4y equal minus 66 equal to 0. Again we are comparing all the terms with a1 by a2 and b1 by b2 and c1 by c2. We write it as 1 by 2, 2 by 3 and minus 30 by 60 minus 66. Now comparing all the ratios, we get the expression as a1 by a2 is equal to b1 by b2 and b1 by b2 is not equal to c1 by c2. Here the algebraic expression is inconsistent because both the terms first a1 by a2 and b1 by b2 are equal, but c1 by c2 is not equal to a1 by a2 and b1 by b2. Now on the graphical representation, we notice that it is a parallel lines or a parallel path. Parallel path is nothing but, for example, railway track. Railway track, they doesn't intersect with each other. They intersect or they match each other at a junction. So here in both the expressions, we know that they are in a parallel path. We don't know where they can intersect. So we consider it as parallel path. There is no solution in the given expression. Now coming to the third one, 3x plus 6y minus 3900 equal to 3900 and 2x plus x plus 2y equal to 1300. Here a1 by a2 and b1 by b2 and c1 by c2 is written as 3 by 1, 6 by 2, 3900 by 1300. Here comparing all the ratios, we observe that a1 by a2 is equal to b1 by b2 equal to c1 by c2. Now the algebraic expression is consistent and it is independent with each other because all the terms are being equal. Now coming to the graphical representation, we notice that all the terms are being equal so that the lines or the equations or the expressions are being intersecting with each other. So we call this as coincident of graphical representation because both the expressions are been intersecting with each other and they are been coincident with each other. Now coming to the solution, there are infinite numbers of many numbers of solution on a same point. We can notice many numbers of point being intersecting with each other. Now coming to the next method, algebraic method. Here in this method, why we should consider this method? Because there are some reasons. Here we have learned how to solve a pair of linear equations graphically, but the graphical method is not convenient in case where the point represented in the solution has no integer coordinates. For example, when the solution is in the form of root 3 comma minus root 3 comma 2 root 2 minus 1.75 comma 3.3 4 by 13 comma 1 by 19 etc. These expressions we cannot notice on the graph, so we have to consider the algebraic method. In this method there are every possibility of making mistake while considering or while reading such coordinates. If there any alternative method to find a solution, there are several other methods, some of which we shall discuss now. In this first method, we are going to discuss about substitution method. This method is useful for solving a pair of linear equations in two variables where one variable can easily be written in terms of other. To understand this method, let us consider stepwise. First one of the equations express one variable in terms of other variable, say y in terms of x or x in terms of y. We can consider in both ways and we can write both the expressions in for the types, for the ways, y in terms of x and x in terms of y. In the second step, we need to substitute the value of y. We need to find by substituting the y expression in terms of other expression. In the second equation, we have to substitute y value or y equation and we have to find the value. By substituting y expression in the equation 2, in equation 1, for the second equation, we get the value of y. For the third step, simplify the equation obtained in step 2 and find the value of x. We have to find the value of x by substituting the value of y or the expression of y in the equation 1. In the fourth step, substitute the value of x obtained in step 3 in either of the equations and solve it for y. We have to take the y value and substitute in any one of the equation, or it may be equation 1 or 2 or 3, which is being convenient to us to find the other variable. By this we can solve and find the value of y. Now in the fifth step, we are doing a check method, means we are verifying that whether the values of y and x are being correct or wrong by substituting these two x and y values in the given original expression or original equation. We can notice that these equations are being correct or not based on the values which we get. If the expression is equal to 0, then we can say that both the values are being equal. Coming to the example, solve the given pair of equations using substitution method. In this, we are considering an expression 2x minus y equal to 5 and 3x plus 2y equal to 11. Now coming to the solution, 2x minus 5 y equal to 5 consider as equation 1 and 3x plus 2y equal to 11 as considered as equation 2. Now equation 1 can be written in terms of x, y in terms of x. Here we are considering, I am writing the term y in terms of x. Y equal to 2x minus 5. Substitute in equation 2. We are substituting this y expression in terms of x. We are substituting this y term in equation 2. We get 3x plus 2 into 2x minus 5 equal to 11. 3x plus 4x minus 10 equal to 11. 7x equal to 11 plus 10 equal to 21, where x equal to 21 by 7 is nothing but x equal to 3. By substituting this x equal to 3 in equation 1, we get 2 into 3 minus y equal to 5. Y equal to 6 minus 5 equal to 1. Substituting the values of x and y in equation 2, we get 3 into 3 plus 2 into 1 equal to 9 plus 2 equal to 11. But both the equations are satisfied when by x equal to 3 and y equal to 1. We have checked both the terms by substituting one of the equation. By this we can notice that both the values of x and y variables are same and it is being correct. Coming to the next method, elimination method. In this method, first we eliminate or remove one of the two variables by equating its coefficient. This gives a single equation which can be solved to get the value of other variable. To understand this method, let us consider stepwise. For the first step, write both the equations in the form of ax plus by equal to c. For the second step, make the coefficients of one of the variables, say x, equal by multiplying each equation by substituting real numbers. For the third step, if the variable of to be eliminated has the same sign in both equations, subtract one equation from the other to get an equation in one variable. If they have opposite signs, then add it. Coming to the fourth step, solve the equation for the remaining variable, and then in the fifth step, substitute the value of this variable in any one of the original equation and find the value of eliminated variable. Now coming to the example, solve the following pair of linear equations using elimination method. First equation as 3x plus 2y equal to 11 and second equation is 2x plus 3y equal to 4. Coming to the solution, here we need to consider first expression as equation 1 and second expression as equation 2. Let us eliminate y from the given equation. The coefficient of y in the given equation are 2. So 2 and 3. So LCM of 2 and 3 is 6. We need to multiply 1 by 3 and 2 by 2. By multiplying equation 1 into 3 and equation 2 into 2, we get the expression as 9x plus 6y equal to 33, 4x plus 6y equal to 8. By this we can solve and eliminate the variable y, and we get the expression as 5x equal to 25, x equal to 25 by 5 equal to 5. Now substitute this x equal to 5 in equation 1. We get 3 into 5 plus 2 into y equal to 11. 2y equal to 11 minus 15 equal to minus 4 equal to y equal to minus 4 by 2. We get y equal to minus 2. Therefore the required solution is x equal to 5 and y equal to 2. By this we complete the pair of linear equations in two variable methods. By this we can complete this chapter and I suggest you to solve all the problems which are related to pair of linear equations and comment me on the comment box by giving your doubts or clarifying your doubts by solving other textbook methods or considering any different methods, and notice me if any difficulties or if any misunderstanding which you have not understand in any problem or any method. Please notice me, and thank you for watching this video. Please like, share and subscribe. Thank you.